These next problems are to solve, and to solve means to find the solution. We also know solutions are known as zeros or x-intercepts. There are many different ways to do that. One of the first ways we found solutions were by looking at a graph. So you need to be able to look at the graph and say, okay, it crosses the x-axis here at -2, and it also crosses the x-axis at +1. So the solutions here are x equals -2 and x equals 1. Or you can write that as -2, 0 and 1, 0. Not quite so easy on this one. Looks like we're going to have to factor, but they all three share a 2 because they're all even numbers. So we can pull out a 2 and we'll see that we have 2x squared minus 7x minus 4 equals 0. Because we're solving and we're not just factoring, we can either just leave that 2 alone or go ahead and divide by 2 on both sides. If there was a variable there, we couldn't do it, but because there's not a variable, we can do that. Please remember that you can only do this when you're solving, not when you're just factoring. This 2 is a part of the factors. It just doesn't have a variable, so it doesn't help with the solution. It doesn't have any place in our finding the solution. This really just means this 2 makes it stretch out by a factor of 2. So now we have 2x squared minus 7x minus 4 that needs to be factored. So we're looking for two things that multiply to make -8 and add to make -7. -8 can be found by 1 and 8 or 2 and 4. It looks like if we have a +1 and a -8 and we add those, we would get -7. So I'm going to rewrite this as 2x squared minus 8x plus 1x minus 4 equals 0. And then I'm going to separate these two and factor by grouping. So out of the first one, I can see it has a 2x and 1x left over, and then minus a 4. And we'll keep the sign that's there. And then we have a 1 here, and x minus 4. The only thing that these share is a 1. Still all equal to 0, even though I ran out of room there. And now this term shares an x minus 4 with this term. So I'm going to go ahead and pull out that x minus 4. And these two are what's left, 2x plus 1. And then I'm going to use the zero product property and set each one of them equal to 0. And I'm going to solve and get x equals 4 and x equals -1/2. Those are the two solutions for that one. This one here, I've kind of ran out of room, so I'm going to rewrite it up here on this blank paper. But this problem is 2x squared plus 26x equals -24. So if you remember the day I went around the room and was like, what are we going to do first? What are we going to do first? And then I gave you the piece of paper that technically, first, we don't take out the GCF. Although we could, it would make it a little more difficult. First, we want to make sure it's in standard form. This is not standard form because it's not equal to 0, and my A, B, and C are not all on one side of the equal sign. So I'm going to go ahead and put this in standard form by adding 24 on both sides. So now I have it equal to 0. And then again, they all share a 2. So the greatest common factor here is a 2. So now it looks like I have 2 times all of this. Now I'm going to do it a little different this time just in case when I divide it by 2 on both sides it messed you up. So I'm going to go ahead and leave that there. I'm going to come off to the side and say what two things multiply to make 12 and add to make 13. Obviously it's going to be a 1 and a 12. They're both positive. So it's x squared plus 1x plus 12x plus 12 and do what I've been doing. These two share an x. And then what's left is x plus 1. Keep the sign. These two share a 12. And then what's left is x plus 1. And now I can see that these two are going to share an x plus 1. Still have this 2 out here, so we have x plus 1 times x plus 12 equals 0. And now I'm going to use the zero product property. Well, we know 2 cannot be equal to 0. That doesn't make sense. So I'm going to divide by 2 and get rid of that. Have x plus 1 times x plus 12 equals 0. X plus 1 equals 0 means that x equals negative 1 is one solution. X plus 12 equals 0 means that x equals negative 12 is the other solution. The next thing I'm going to show you is how many real solutions do each of these have. Well, if I'm looking at 3 different quadratics here, remember a solution is a 0, a root, or an x-intercept. Because this one only crosses the x-axis one time, it has one solution. Because this one is going to cross the x-axis 2 times, it has 2 solutions. And because this one is above the x-axis and going up, opens upward, it's not going to have any solutions. That is something we will use later. I'm hoping that you can piece that part together with how we've talked about what an x-intercept is and how it's a solution. So you do need to know this, but we'll start using this a little bit later. All right, something we've done before is find the domain and range. Well, I have an equation here. I could find the zeros. That's not really going to help me any. So factoring or square rooting or solving, none of that's really going to be useful when I'm just looking for domain and range. So the domain and range, we should all know that a parabola is always going to have a domain of, you got it, all real numbers every time, unless there are some sort of restrictions, and we don't have those. Because it's minus 4, this parabola is shifted down 4. So if this were negative 4 right here, that's where it would cross. Because it's shifted down 4, we know the range is going to be from that lowest point, negative 4, all the way up to infinity, because these arrows mean it's going to go to infinity. Also, it's going to include negative 4, so we use a bracket. This should be just review for you. Alright, and then if you were asked to write an equation for a graph, and you were given these zeros here, these x-intercepts, I would hope you could say, well, I know these zeros are x equals negative 1 and x equals 1. Which means that if I were to add 1 on both sides, I would get x plus 1 equals 0. And if I were to subtract 1 on both sides, I would get x minus 1 equals 0. And these look very much like what we would do when we factor. We just kind of went backwards. So x plus 1 times x minus 1 equals 0 would be an equation. Now, question is this the only one that could work with these two zeros? And that answer is no. We want to make sure we have the one that's right. So the y-intercept needs to be negative 1 in this case, which we can see that if we do last times last, we would get negative 1. So that c value would be negative 1, meaning the y-intercept would be negative 1, and this is correct. I don't know how much of this you're going to need to be able to do for the test, but you definitely need to understand this concept of taking two zeros and turning them into factors into an equation.